Less than 1 year from now, we will capture the first CO2 in Brevik and transport it for permanent storage. We are looking forward to it. Okay. Yes. So, doing such a big project is not possible without people and teamwork. So, since this is a very historic project, that's what we think at least, then in the middle of April, we gathered everybody who was involved in the project, from all the contractors, to take this group photo in front of the future CCS plant. So we had Heidelberg Materials, we had a sub-supplier, Aker Carbon Capture, FL Smith, and a lot of other contractors, civil contractors. I will not go through the agenda, but I will promise you that the most interesting point is the last one, is number 5. And that will be takeaways which you can use for your project out there at your cement plant. I will quickly go through the history and development of Brevik CCS. So, approximately 10 years ago, we started doing different kind of testing at the cement plant. So we had 3 pilots, 2 pilots using amine, and 1 pilot using a membrane. And then there was also some university testing being done in Germany. It was quite quickly clear that the only mature technology was that of Aker Solutions, which is now spin-off in Aker Carbon Capture. So that's the reason why a bit later we choose that technology to continue. So we made in 2016 a feasibility study, we made some concept studies in 2016 and 17, then we made a feed study together with Aker Solutions at that time. And then in 2020, the Norwegian government chose to fund the Longship project with 2.5 billion euros, consisting of emitters, capture the emitters, and of course ships, transportation, a compressor station, and a pipeline going out into the North Sea. And we aim to finish the project next year. So we'll do mechanical completion this year, and then we'll have a period of half a year of commissioning before we'll be able to fill the first ship with around 1,000 tons of CO2. Just speaking a bit about the Longship project today. So a lot of speakers already spoken about it, but I'll just do it briefly. So we have Brevik CCS up there, and then there's also an emitter in Oslo, bit towards the south of the city, which is a waste incinerator, which also sometime in the future will provide CO2 for the facility. And then there are some nice ships from Northern Lights which will transport it out to the west coast of Norway, and then it will be pumped down into the seabed for permanent storage. And I have been told the ship should be ready by, at least one of the ships should be ready by this year, at the end of the year here in Norway. So that's pretty good news. So I will just go a bit into the technology, just so we're all on the same playing field here. So the flue gas we will pump into the DCC of the fan into a direct contact cooler. There we wash it with water, so we get the temperature down to 30 degrees centigrade. And then the flue gas goes into the absorber in the bottom, and the flue gas of course goes up, and then it is washed with amine, which basically sucks out the CO2 from the flue gas. And then the nitrogen, the oxygen, some water leaves the stack at the top. And then we have something called rich amine. The rich amine is then pumped via some heat exchangers to the desorber. In the desorber, we increase the temperature with a lot of the waste heat we have from the plant to 120 degrees centigrade, and then we release the CO2 in a relatively pure state, together with some trace elements, a bit of water, oxygen as well. And then it's transported to the compressor station where we liquefy it. And I know the box there is pretty small. In reality, that box is pretty big. It's probably the biggest part of the plant, but you will see that. And then we pump it to the storage facilities where we have 6 tanks with a total capacity of around 6,000 tons. And then a ship will come every 3-4 days to pick up our CO2. So this is the plant, how it looks. All the gray buildings, that's the existing buildings, of course. And then we have the red color, that's all auxiliary stuff, temporary stuff. Then we have the green color, that's all the equipment supplied by Aker Carbon Capture. And we also have orange piping, ductwork, filters, all the things which are very familiar to people in the cement industry, delivered by FLSmidth. So they're actually responsible for the plant integration between the CO2 capture plant and the cement plant. And as you can see here, we are aiming for a 50% capture rate, and that is defined by the available waste heat we have at the plant. So if we had more waste heat available, we would also capture more CO2. But if we should capture more CO2 at the moment, we should do it with electrical energy, and that's going to be expensive even in Norway. So now we stripped off all the civil buildings. Now there's only a maintenance center left and some piping of the plant, the CO2 plant. The absorber is the highest construction of the plant, 100 meters high. Then you have the desorber, which is kind of the second highest building. And then over here you have waste heat recovery units on the cooler side. We have 4 waste heat recovery units here on the flue gas side. And then on the raw mill side, we have 3 additional boilers over here. And you're probably thinking, why is it so far away from the actual plant? And that's because of space considerations. So it actually goes over the road on this other side of the plant. It's a very compact site in Brevik, I have to say. So here you see it from above, the absorber, the desorber. Below here you have the liquefaction module, and below that you have a lot of heat exchangers doing the heat exchange between these 2 units. You have the waste heat recovery units here on the main gas, the gas coming in here to the absorber. You have the waste heat recovery units for the cooler here. Then you have a tank farm here for amine. You have waste heat, so different water treatment facility here. And over here, you can't really see it here, out here you have a seawater intake, because we use seawater to do the cooling of the flue gas over here. Here, to be precise. And then we have a lot of orange stuff, the integration with the cement plant. And when the CO2 has been liquefied, it is sent to the storages, which is around 700 meters away from the plant. And then we have another 160 meters of underground pipe towards the loading arm to the ship. So now I would like to show you a bit what happened in between the FEED and the actual project when we did the detailed engineering, because it probably will surprise you a bit, because the FEED is only that good, right? It doesn't go into a lot of detail, so the detailed engineering will look a lot different. So here we have the main process area. So absorber again, desorber, some heat exchangers, liquefaction module, and so on. This is how it actually looks in real life. So a lot of additional piping. Just go back. This is how it looked in the FEED, and this is how it looks nowadays. So just be aware that it's important to make a good FEED. And this is for the compressor module. So over here we have the FEED, and here we have how it looks like nowadays. And there's actually a lot more in this building, because we have some auxiliary piping, we have an electro boiler of 8 megawatts, and so on and so forth. Yes? Now I'll show you how it developed. I know some pictures have already been showed, and that's fantastic. So if you go back to 2021, we were fast and furious, demolishing a lot of old equipment on the plant from, I think it was kiln line 5, 4, okay, don't really remember it. We demolished the maintenance area for the mechanical guys, so they were not so happy. 1 year after, in March 2022, we began constructing a jetty, and you might think, why is a CO2 project constructing a jetty? That's a bit of a peculiar thing, right? We need the jetty because we need some way to transport all this heavy equipment into the site. And a lot of the piping has been pre-manufactured modules. So we also had to barge in the modules and transport them by what we call SPMTs. And then put them in place with very big cranes. You'll see some of the pictures later. At the same time, Aker Carbon Capture was busily manufacturing the equipment at their sub-suppliers for our project. So here on the left, you can see waste heat recovery units being manufactured in Finland, and they look pretty much like cement stuff, carbon steel, pretty usual stuff. And then you have here on the other side the drying and reclaimer packets, which does not really look like cement stuff. Now we're already in the oil and gas industry kind of stuff, and chemical industry kind of stuff. The compressor, I think this looks very much like the compressor you saw yesterday from Siemens. It's not, it's from MAN, but the principle is the same, so I'm not really going into the details. In August 2022, we were finished with the piling of the main process area. So that was yet another milestone, which was finished. Good. Then that year we began moving in, craning in the big waste heat recovery units. I think the weight is around 50 tons of each module, so it's kind of a big piece of equipment. And we have 9 of those to recuperate around 33 megawatts of waste heat. And here in November 2022, I really love this picture because there's so much activity on site. Maybe not so many people, but at least there are a lot of cranes and things on site. And you can also here see how cramped it is. We don't have a lot of space, and this is probably taken with wide angle, so it's cheating a bit. And then we are in April last year. Now we basically have made all the major civil structures, and we're ready to take in all the big pieces of equipment. And here you can actually see that we have the absorber and we have the desorber lying ready on the barge to be moved into the construction site. And here, this picture you have probably seen before if you are following us on LinkedIn, of the absorber being lifted into position in the main construction area. Same time, we also lifted in the CO2 tanks. I think they're around 250 tons, so they're also a delicate operation, also because they were pre-insulated. We don't really want to destroy insulation on these tanks. I'll come back to that regarding the insulation. And then, not so long time ago, it was this year, we lifted in the desorber. And the reason why we didn't do that earlier was because we had to lift in and do some work before we were actually able to lift in the desorber. So some modules had to be finished first. One area which is pretty finished already is actually our loading arm. And those of you going to Brevik tomorrow will be able to see it firsthand from the sea. The only thing which is missing here is basically insulation and a bit of electrical work, then it's just to push the button. So this is basically how it looks now, and we are 78% complete. Maybe a bit more, because these numbers they're already 2 weeks old. So now it's time for you to check out your notebooks, because this is where you can maybe get some information for your own project takeaways. So I will not speak about COVID, because the project was also hit by that, but that's a long time ago. We have postponed construction of the maintenance center because we don't have space. We need that area for rigging. So again, like in all cement projects, don't underestimate the amount of space needed for the actual construction. Then we had some cement equipment, filter, gas conditioning, and all this stuff, which were not really in the state which we expected it to be, so that had to be renovated, of course. Then we had been moving the CO2 loading location a few times, and that was also not for free to do a location change every time late in the project. So basically, all this has ended up with a cost increase. You can see that on Gasnova's website, how much the cost has gone up for this project. And project delays of around 10 months compared to the original time schedule. So now I'll take one of the key takeaways which we have learned. So Heidelberg Materials, we're a cement company, as you know, and we have not been doing really business with oil industry before, definitely not been buying from suppliers to the oil industry. So this is something pretty new for us, and it's actually more difficult than one might think, because there's so much difference in the culture. I mean, we know how the ThyssenKrupps work, we know how the IKNs work, we know how the FLSmiths work, but we don't really speak the same language as the oil and gas industry. And just one example, this is the reality at many cement plants. You have some piping, it's a bit rusty, and it's fine, it works. But this is like what we have now. This is the future, this is CCS, right? You have stainless steel piping, 316 stainless steel, fully welded pipe supports, properly checked with NDT, and you name it. That's kind of a different ballgame and a different price tag. So that is very important to take into account when you engage with a supplier upfront and in the early phase, to get an alignment on the expectations. Also to say, of course, that doing this project has greatly benefited internally in Heidelberg Materials all the other projects we have in the pipeline, because we have learned a lot, really a lot, for sure. And that's also something you should think about when you're doing the first project. Doing a publicly funded project is maybe not more difficult than doing other projects, but I'm quite sure that almost any other company will not have the same amount of reporting requirements as the state would have. We simply need to allocate people to sit basically and write reports to the state. That is something which we are not used to. Other lessons learned is get a piping engineer. If you don't, and the cement industry probably don't have a piping engineer in-house. I mean, yes, of course you have a plumber at your cement plants, for sure. But I would recommend to get one with vast experience of different piping qualities, sourcing of piping, and a bit of all-round knowledge, because we could have used that a bit earlier. But we didn't think about it, of course. We're doing an operator training simulator, which I might say it came out to be relatively inexpensive and compared to the value you get out of that. So right now we're actually testing situations in software, so they will not happen during commissioning. And hopefully that will shave off days, maybe weeks of problems in real life. So that's only a very good recommendation. Yeah, and then of course separating the CCS facility from the existing cement plant, if it's possible, please do so. And please also consider having a lot of extra space maybe. Just for one example, we had to build the compressor building 2.5 meters taller than it originally was intentioned. Of course, in the height it's normally not a problem, but what if it would have been 2.5 meters to the side? It would have been a bit more problematic. Another lessons learned, we have faced the scaffolding. I don't know, I have not seen so much scaffolding in any cement project as we have on this one. I mean, the whole site has been covered in scaffolding everywhere, and we don't really understand sometimes what is going on. So just this example, this is the CO2 tank farm. So we have 6 big tanks in here, which are 24 meters high, and they're all covered with scaffolding and heated up, and so on and so forth. more or less because they are doing, they're installing insulation in the wintertime. If this was done in the summertime here in Norway, a lot of this weather covering would not have been necessary. So also pretty important to think about that. Again, speaking about CO2 tank farm, they came delivered, placed on cradles, and these cradles were of course not insulated because then the insulation would have been damaged during transportation. So they had to be insulated on site. And that's also something to think about. If you don't have a specialist on cold insulation, get one during this just to make sure that it's made correctly, because when these tanks will be in operation, filled with liquid CO2, minus 26 degrees, you don't want to have an ice build-up in between the steel and the insulation. That's going to be a big headache to repair. So potentials for cost savings in the future. Well, this fan is something we've seen many times before in the cement industry. Typical small process fan. This one, okay, not small, it's still higher than me, right? But it was pre-manufactured completely by a supplier and sent to site, where we would probably normally in the cement industry have built a foundation on site and put in a pillar and some casing, and off we go. So it's a different mindset. I'm not sure this is an inexpensive solution. It's a nice solution, yes, but it's definitely not an inexpensive solution. The same game goes with the requirements of documentation. This is oil and gas. This is what we would normally require in the cement industry. Pipe supports, I showed you earlier that they were made of stainless steel. They could have maybe, some of them could maybe have been made in galvanized steel, and then thereby reducing cost. Also something to speak with the supplier about before you engage in the project, because stainless steel is expensive. Another interesting thing is equipment preservation. Well, when I was working with FLSmidth, it was like, yeah, just go out and remember to turn the shaft on the motor once a week, then, just, before startup, a few months before startup, then everything will be fine. Well, this is very different attitude. This is like you have plastic bags over all the valves and everything, sometimes even twice, to ensure that no dust will come in and it will work flawlessly when you go into operation. Another recommendation is from my side is that use the supplier standard specifications. I mean, if the equipment is good enough for the Swedish nuclear industry, it's probably also good enough for carbon capture. And in this case, it was a wastewater treatment system, indoor, no dust. Other things which should be considered is doing engineering, that is pipelines for liquid CO2. Good idea that they can be drained, otherwise you will have problems. CO2 venting, CO2 compressor, blow-off scenarios. Every time you need to get rid of some CO2, blow off something, you need to think about where to do it from the beginning, and not later in the project. And also modules versus in situ installation of piping. So in this project, everything came by modules. That's a fantastic solution. You can do the modules in a workshop, finish them, and then you can transport them. However, if you suddenly want to change the sequence, installation sequence, you're locked. You have to finish these modules in a certain sequence. But if you did, let's say, stick build on site, this would not have been a problem. So that's also something which must be taken into account when you do such a project. So now it's basically just your turn to do the next project.
Thank you. Thank you very much indeed, Anders, for giving us a really realistic, we might say, warts and all overview of the project, some of the problems that you had, and I think this presentation on its own might save some of the listeners here who might be thinking about indulging in carbon capture, potentially tens or millions or tens of millions of euros. So it was valuable for us all. Thank you very much indeed. Are there any questions from the floor? Please.
Not from Loist. This project has taken you 7 years from feed to operation, from 2018 to next year. If you do this again, so the second time, how long will it take you?
That's a good question. I think you could shave off maybe 1, maybe 2 years, but not more than that. That's my guess.
One back here. That's it.
Thank you very much. In terms of cost or capital cost, you have a number that we can take a sense. Second point is, what are the sheer amount of the contingencies that you would recommend for a first project, no? For a team or for a company, and what could be in line with the previous question? What would be your expected cost reduction in the second project that you would encounter?
Regarding capital cost, I think the official figures is around 450 million euros. But you can find official figures on Gasnova's website because it's a publicly funded project. So that's our part. When it comes to contingencies, that's a good question. I'm not really sure what to answer, but under no circumstances go below 10% maybe. You need to have ample contingencies, but it also depends a bit on the split between how much civil do you have. Civil is pretty well known, right? So there shouldn't be any big problems there. And how do you put contingencies on, let's say, the CO2 capture part of the plant? I mean, that's pretty difficult, I would say. And also the integration part. It also depends a bit, how well do you actually know your cement plant and all the problems on your cement plant. False air, very good idea to work on false air as early as possible to make sure you don't have 15% false air when you'll be starting the plant. You need to have the false air, which is the amount of CO2 and the flue gas, which is specified in the contract when you start. Otherwise, you will have a headache when it comes to performance guarantees.
Final question from John. Thanks.
How important was it to have your 3D model made before you did the construction?
Wow, the 3D model has been essential. We have it has been extremely good to have a 3D model, both during feed and also during the construction phase. We updated the 3D model, I think, during the engineering phase once every week. And now we are down to once every month. But the 3D model is in essence the most important, let's say, document we have, and is also very important for the commission. The commission for sure, but also during operation, because basically what I've been told by the operational people is that they will use the 3D model as the basis for basically everything in the future.
Anders, you're the project manager for the plant. How have you been sleeping?
At times better than other times, I would say.
Yeah.
Right now it's going pretty well, I would say, but we have had our, let's say, struggles and nightmares at site, absolutely.
Okay, and you, having been the project manager for this, you will become extremely valuable. You've done it. You will have been the guy that did it. Do you think you would do another one of these?
Well, I would like to do another one, but a different plant, right?
Okay.
So definitely.
Somewhere warm.
Sorry?
Somewhere warm.
It doesn't really matter. I've been working in Russia, so it doesn't really matter.
Yeah. Would you use the same technology?
I personally, and this is my personal feeling, is that I think oxyfuel will be a cheaper solution in the future, sometime in the future. I mean, we choose the amine technology because it was possible at that time. It was a mature technology. Right now, oxyfuel, I don't think anybody has an oxyfuel plant operating, full scale. So this is what is possible at the moment.
Okay, and final question. How long do you expect this plant to be operational for?
Oh, I don't know what is. I think it's designed for at least 20 years. But my guess, with the very high grade equipment in place, it will be operating flawlessly for a longer time than the cement plant.
Okay. Wonderful. That is all the time we have for questions, but for his excellent presentation, let's give a resounding round of applause for Anders Peterson. Thank you very much.